Hey there. All right. This is AP Calculus Lecture 2.1a. So we're in section 2.1 of the book. And this is part 2 of the lecture. This is where I'm just going to work example problems from all the theory that we learned in the part 1 lecture. And this is the equation that you've got to memorize that we're going to keep going back to. This is the formal definition of the derivative. Now, these problems that I'm going to work today are long, but they get easier because I'm going to be able to show you a lot of shortcuts to this equation, starting with, I believe, the next lecture. But the limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. We're going to use that for all three example problems that we're going to work. So our first example is find the slope of the tangent line to f of x equals 2x squared at the point x equals 3. Okay, so that's all that f prime of x tells you. The derivative tells you the slope of the tangent line. Okay? And then, so first of all, we're going to find f prime of x, and then we're going to plug in 3 to that to get the slope. Okay, so we're going to start. I'm just going to write this equation again. F prime of x is equal to f of x plus delta x minus f of x over delta x. Now we're going to use this. This is our f of x. So f prime of x. What is f of x plus delta x? Well, wherever you have an x, you just put in x plus delta x. So f of x plus delta x is 2. So we're working off of 2x squared. 2 times x plus delta x all squared. That's f of x plus delta x. Instead of 2x squared, we just put a x plus delta x in. Minus, what is f of x? It's 2x squared over delta x. Okay, I am going to, got a cat hair there. I am going to expand that x plus delta x squared. So we're just going to FOIL that out. Now, I won't do this every time. We'll do this on this first problem. That's the same thing. X plus delta x squared is just that. So if you FOIL that out, it's going to be x squared plus 2x delta x plus delta x all squared. Try that yourself, just foiling it, and that's what you'll end up with. So we have a 2 times that, x squared plus 2x delta x plus delta x all squared minus 2x squared. And by the way, I'm so sorry. We're taking the limit as delta x approaches 0 on all this. So take some time to smush that in there. I apologize. Over delta x. All right, so we're going to take the limit as delta x approaches 0, and let's clean this up. Let's distribute the 2. So that would be 2x squared plus 4x delta x plus 2 times delta x all squared minus 2x squared over delta x. So any of the terms that don't have delta x in it suddenly go away. 2x squared minus 2x squared. So we're at the limit as delta x approaches 0 of 4x delta x plus 2 times delta x all squared over delta x. Now we can factor a delta x out of the top. So what's left if we factor that out? It's going to be 4x plus 2 delta x over delta x. This is what we were trying to get to. That's the 0 over 0 that we're trying to eliminate as long as delta x does not equal 0. So now we're at the point where we can plug zero in for delta x and get an answer. Okay, plug 0 in right here, this term goes away, and you're just left with 4x. So 4x is the equation for the derivative. F prime of x is equal to 4x. So the slope at x equals 3, you just plug 3 into this equation. So that's going to be 4 times 3, and the slope is 12. Okay, so these problems are tedious, but your future is filled with me showing you shortcuts to this tedium. And you'll be able to find the derivative much, much faster. But we have to learn to take derivatives using the formal definition first. Okay, our next example. An ant is crawling on the floor. Its location in feet at time t in seconds is given by P of t. So instead of f of x, we're using P of t, but it's the same process, is equal to t squared plus t. Okay, so question A is, where is the ant located after 2 seconds? And question B is, how fast is the ant moving? So that's, what's the ant's instantaneous rate at that instant, or at 2 seconds? Okay, part A is nothing new. That's just things you learned in algebra. It's P of 2. So P of 2 would be 2 squared plus 2. So that's 4 plus 2, so 6 feet. So that ant is fast, isn't it? Part B, though, we have to go through the process of taking the derivative. So P prime of t, I'm just going to rewrite this equation with p's and t's, is equal to the limit as delta t approaches 0 of P of t plus delta t minus P of t over delta t. And I've got to fill that in. Well, that's equal to the limit as delta t approaches 0. Well, what is P of t plus delta t? Right up here, look, anywhere there's a t, you put t plus delta t. So P of t plus delta t would be t plus delta t all squared plus t plus delta t. That's part is P of t plus delta t. That's this. Because it was t squared plus t, so we do a t plus delta t, square it, and then t, we put in t plus delta t. Now minus P of t would just be minus t squared plus t, but I'm putting it in parentheses because we have to subtract that whole thing, and I don't want to forget to distribute it. Okay, so that's the limit as delta t approaches 0. We're going to FOIL that out, expand that. Okay, so if you wrote that twice and FOILed it, it would be t squared plus 2t delta t plus delta t all squared plus t plus delta t. All right, we're right here. minus t squared minus t. So a bunch of things are going to cancel out over delta t. So the t squared cancels, negative t squared. T, negative t. And you get the limit as delta t approaches 0 of 2t delta t plus delta t all squared plus delta t over delta t. Now we're going to factor out a delta t out of the top. All the terms have delta t in it, so we can factor it out. You'd have a 2t left there, a single delta t. And then if you factor out a delta t out of a delta t, what do you get? All right, well, I've already written it down. You get a 1, right? Now we can cross out. That's the 0 over 0 that forced us to do all this work. As long as delta t does not equal 0, we can take the limit as delta t approaches 0 of 2t plus delta t plus 1. I plug in a 0 for delta t, and so p prime of t is going to just be 2t plus 1. That's our equation for the derivative. But we want to know how fast the ant is going at 2 seconds. So that would be what we call p prime of 2. We're going to plug 2 into the derivative. So that's 2 times 2 plus 1. That's 5 feet per second. The distance is in feet, the time is in seconds, so it'd be 5 feet per second. All right, pretty cool. Now when I show you the shortcut, I'm going to save you a ton of time on a problem like this, but we have to learn it this way first. Okay, our third and last example problem of this lecture is we're going to let f of x be 5x squared minus x plus 3. What is the tangent line equation to f of x at the point 1, 7. So I'm going to erase this. I'm going to draw out what we're talking about. This is a parabola. And we're just asking, okay, what's the equation to the tangent line at, let's say, the point 1, 7 is right here. We're trying to get the equation of that tangent line. So if that parabola is f of x at the point 1, 7, what's the equation of this line that's tangent to that parabola? That'll tell you, instantaneous rate of change at the point 1, 7. Okay, so we're always going to start with this equation. I keep writing it out because you do have to memorize it. The limit as delta x approaches 0 of f of x plus delta x minus f of x over delta x. Now this is a little longer equation, so it takes a little more room. I'm hoping I can squeeze it into this. F of x plus delta x, we're just where there's an x, I'm going to put x plus delta x. So that'd be 5 times x plus delta x squared, because the x is squared, minus, I'm going to put this all in parentheses, x plus delta x plus 3, you don't have to do anything with that, minus f of x, which is 5x squared minus x plus 3. But I put it all in parentheses because I have to distribute that negative sign over delta x. Let's clean that up. Okay, I'm going to so first of all, x plus delta x all squared. That's going to be 5. Let's go ahead and square that term, FOIL it out. It's going to be x squared plus 2x delta x plus delta x all squared. Multiplied all that by 5 minus x minus delta x plus 3 minus 5x squared minus minus makes a plus x and then minus 3. That's why I put the parenthesis around all this so that I don't mess up the distribution of the negative sign. So that's the limit as delta x approaches 0. Let's distribute the 5. 5x squared plus 10x delta x plus 5 times delta x all squared minus x minus delta x plus 3 minus 5x squared plus x minus 3, and a bunch of stuff is going to cancel out here over delta x. 5x squared cancels. Plus 5 minus 5. Negative x right here, positive x. Positive 3, negative 3. So we've got the limit as delta x approaches 0, and that's 10x delta x plus 5 times delta x all squared minus delta x. That's all that's left. Now tell me what you're going to do to the top based on the previous two problems. I won't be able to hear you. What are you going to do to the top? Factor out a delta x. So now you have 10x plus 5 delta x minus 1 over delta x. Can cancel. That's the 0 over 0. We can cancel out as long as delta x does not equal 0. And we have the limit as delta x approaches 0 of 10x plus 5 delta x minus 1. Now we can plug in the 0, and your equation for the derivative is just 10x minus 1. That is equal to f prime of x. Now, in order to get the equation of the tangent line, because we're not just getting the slope, we have to get the slope, and then we have a point. So our tangent line slope is equal to f prime of what? Okay, we have our point here at 1, 7. You plug the x value in, which is 1. So f prime of 1, that's 10 times 1 minus 1. We're plugging 1 into this x right here. So that is going to be 9. We have a slope of 9. Now remember, your point slope form is y minus y1 is equal to the slope m times x minus x1. We did that a lot in Algebra 2 and Pre-Cal. We have a slope, but we also have a point. Our point is 1, 7. So it's going to be y minus 7 is equal to 9 times x minus 1. And that's fine. Just leave it like that. You don't have to convert it to slope-intercept form if I don't ask you to. So there you go. That's your tangent line equation. Now I'm gonna have to erase a little bit here to do the second part of the question. So we have our derivative is 10x minus 1. And I've got another question. This will help you with your homework. Let's say part B of the question is, at what x value is the tangent line horizontal? Okay, so what is the slope of a horizontal line? What is that? Well, it's 0. And we know this equation, 10x minus 1, is the slope. So we just set 10x minus 1 equal to 0. And solve for x. So 10x is equal to 1, x is equal to 1/10. All right, that's all there is to it. Okay. So I'm going to give you the homework and then some clues or some hints for the homework. Okay, so the homework is page 99. Look at that. We've already made it to page 99. 7 through 19 odd. Of course, the answers are all in the back of the book. I'm going to be checking your work, so don't just put down the answer. Some hints. On number 11, you will have to expand a cube. Okay, there's a formula for that. We did that in pre-cal, early in pre-cal, but that formula is a plus b cubed, and these formulas are in the front cover or back cover of your book. That's equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. You know, the way we did, I didn't have you memorize that in pre-cal. We just FOILed it out. We just squared it and then multiplied that by a plus b again to get it. That's another way to do it. On number 13, you will have to find a common denominator. So you have to use that trick on the f after you do the f plus delta x. Okay, and on number 15, you will have to rationalize. Okay, so what do you do when you rationalize? You know, you're going to... well, I'm going to let you go there, but we did the rationalization technique in chapter 1, all right? So you're going to have to do that. So that's some hints. Some of the work is pretty tedious. It's pretty long, especially for these 3. But some of them aren't bad at all. They don't take all that long. So I promise you your homework will get shorter very, very soon after we get away from the definition of the derivative. It's just that this particular section, the homework's pretty tedious. All right, I will talk to you on the homework solutions for this assignment.